a silent traveler, 7 billion years old, moving faster than anything we've seen, and it just entered our solar system. But here's the thing, it's not supposed to be here. What is 3I Atlas and why do scientists believe it might be the oldest object we've ever found? Chapter 1. The night we spotted something strange. It was just another quiet night at the Atlas Observatory in Hawaii. The sky looked ordinary. No explosions, no blinking lights, just space endless, dark, silent, but deep in that silence, something moved. But strange enough that the system flagged it. Atlas, short for asteroid, terrestrial impact, last alert system, was designed for exactly this, to find things in space that don't belong. At first, it didn't seem like much, just a small point of light, faint, fast, unusual. Within hours, astronomers realized this object wasn't acting like anything familiar. It wasn't orbiting the sun. It wasn't following any known path. Atlas honors the telescope system that first spotted it, but unlike its two predecessors, 3I Atlas brought a new twist. That's fast, much faster than most objects native to our solar system. It was slicing through space, not circling anything. The path was clearly hyperbolic, meaning this thing came from far beyond our sun, and it's not coming back. Its motion was weird, too fast, too steep, too clean. Even with large telescopes, it was hard to track. Its apparent magnitude was somewhere between 18 and 20, about 100,000 times, fainter than the dimmest star you can see with your eyes. Observatories in South Africa, Chile, and even amateur astronomers worldwide joined in, and in those images taken weeks before the official discovery found it. 3I Atlas had been there the whole time, moving slowly, silently. The Gemini North telescope in Hawaii captured striking images. They showed a point of light, glowing with a mix of blue and reddish hues. Strange, intriguing, beautiful. It didn't look or behave like any natural object. It tumbled strangely. It had no tail. It's from out there, somewhere far away, maybe even a region of the galaxy we've barely studied, because unlike planets or moons, interstellar objects don't stay. No goodbye, just a fading dot in the dark. They don't orbit the sun. They visit and then they vanish. A silent traveler, likely billions of years old, now passing through our cosmic neighborhood. The truth is, we don't fully know. It survived radiation, collisions, and time itself, and for just a brief moment, it came close enough for us to see it. Not yet. It had the gases, the tail, the debris trail. We learned that our solar system isn't alone, that other systems, other stars, and other worlds are still sending pieces of themselves across the stars. It felt natural, still exciting, but easier to categorize. No coma. With older data, scientists could refine its orbit more precisely, and in science, interesting is where discovery begins. They could look further back in time, and they could better calculate where it came from and where it was headed, and it accelerated in ways no one could fully explain. Some even suggested it might be artificial, a probe, a messenger. It was moving along a hyperbolic trajectory, the kind you'd expect from something just passing through, not from Earth, not from Mars, not even from the Kuiper Belt. No, this was different. This was something from outside the solar system. They named it 3I Atlas. 3I stands for the third known interstellar object ever detected after the famous Oumuamua in 2017 and comet 2I Borisov in 2019. See, when Oumuamua showed up, it caught everyone off guard. Then came that one looked more familiar, classic comet, but from another star. But 3I, it sits somewhere in between. The first thing that caught attention was its speed, around 26.5 kilometers per second. Next came the brightness, or rather, the lack of it. 3I Atlas is dim, very dim, almost ghostly. But dim doesn't mean boring. Soon, astronomers pointed more powerful eyes toward it. Then something amazing happened. A man named Sam Dean, an amateur astronomer, was going through archived sky images from the Atlas telescope. That changed everything. This wasn't just a random rock flying by. This was a visitor. The question is, what is it really? Is it a comet, A fragment of something larger? A piece of interstellar junk? Or is it something more mysterious? But one thing is clear. 3I Atlas didn't come from here. It's not from the solar system. The data tells us this object doesn't belong, but that doesn't make it an alien spacecraft. It just makes it interesting. Astronomers around the world are now racing to study it before it disappears forever. And when 3I Atlas goes, it won't leave a trail. Think about it. This object may have traveled for millions, maybe billions of years through empty space. That's not just rare. That's historic. Every time we find something like this, we learn a little more about our place in the galaxy. Maybe it's just rock and ice. Maybe it's a time capsule. Maybe it's something else entirely. But whatever it is, it made it here. And that's worth watching. Chapter 2. What makes 3I Atlas so unusual? So far, we know 3I Atlas didn't come from here. It's not part of the solar system. It didn't form with the planets, and it doesn't orbit our sun. In plain terms, that means it's just passing through. It's moving too fast to be captured by the sun's gravity. The path it follows cuts sharply through the plane of the solar system, as if it didn't care what direction we were spinning in. It's not part of the family. It's a stranger, just walking through the front door, uninvited. It came from deep space, and it's headed back there. That alone makes it rare, but when scientists looked closer, they found something even stranger. This object doesn't act like anything we've ever seen before. Usually, comets get brighter as they approach the sun. Heat makes them release gas and dust. They grow tails. They become more visible. Let's start with its trajectory. Most objects in our solar system follow elliptical paths. They orbit something, usually the sun. But 3I Atlas is on a hyperbolic path. There's no clear calm with a cloud of gas that forms around a comet's icy core. No long, glowing tail. Some light, yes, but soft, faint, that allowed them to refine their calculations, its orbit, its speed, and even its possible origin. It also showed that 3I Atlas had been in our sky longer than we thought. We just hadn't noticed it. Consistent, and no one saw it until it was leaving. Controlled. That one was strange. 2. It didn't behave like a comet, and it had no visible tail. It also accelerated unexpectedly, leading to wild theories, everything from frozen hydrogen icebergs to alien probes. The night sky is full of movement. Thousands of objects fly past Earth every year. Most are small. Some are harmless. Others come and go without ever being seen. More stable, less erratic, and yet just mysterious enough to stir similar questions. 318 LAs is just the latest reminder that we miss more than we catch. That raised eyebrows. It's not tumbling wildly like a chunk of space junk, it seems. Stable. It's not just a mystery. It's a chance to learn, a clue in the puzzle of the galaxy. And right now, scientists around the world are listening. The light had a reddish tint with hints of blue. It didn't match the profile of any known asteroid or comet, but by watching it carefully, we can still uncover part of its history. Some called it a cosmic rainbow. Was it just a trick of the telescope? A color filter maybe, but maybe not. Almost deliberate. And it's not just the shape of its orbit that's strange, it's the angle. Then there's the speed. 318 LAs is traveling at around 26.5 kilometers per second. That's fast, but not chaotic. It's smooth. Next, astronomers looked at the light. It reflects. What they saw wasn't what they expected. Comets made of heavy carbon compounds or icy dust that reflect little light. But 3I Atlas stayed dim. It didn't show the typical signs of a comet. Images from the Gemini North Telescope in Hawaii captured something unusual. When you combine the speed, the angle, the lack of coma, and the strange glow, it paints a confusing picture. Its motion, its light, its shape, all of it is a message. If we can learn to read that message, we can learn about the place it came from. And that's not all. Remember the amateur astronomer named Sam Dean, the one who found 3I Atlas in older images? That discovery changed how we understand the object's behavior. By identifying it in images taken weeks before the official discovery, Sam gave scientists a longer timeline to work with. That's a humbling thought. This object had already passed Earth, already moved closer to the sun. So why didn't we catch it earlier? The truth is, space is big, and our tools, while powerful, are still limited. And what we did catch makes us wonder. Some scientists started comparing 3I-ATLAS to the first interstellar object we found out. But 3I Atlas doesn't behave exactly like Oumuamua. It's dimmer. So, what could it be? Is it a fragment of something larger? A piece of a shattered planet? A chunk of debris ejected from a distant star system? Could it be a dark comet? One made of materials that don't shine the way we expect? Or is it just an old rock, worn smooth by millions of years drifting through space? Scientists are cautious. They're trained to be. They don't jump to conclusions. But even cautious minds agree 3I Atlas is not normal. There's also a deeper idea at play here, something philosophical. Every object in space carries a story. That's the real beauty of something like 3I Atlas. We may never get close to it, we may never sample it, and in doing so, we learn a little more about our own. 31A TLAs is quiet, but it speaks in the language of light, gravity, and time. Chapter 3. Why scientists think it's the oldest ever seen. If someone told you a visitor from another galaxy had just passed by Earth, you'd probably be interested. But what if that visitor wasn't just from far away, but also from the distant past? That's the question scientists are now asking about. 31ATLAs. It's strange because of where it likely came from and when it may have formed. Based on current data, many experts now believe 3I Atlas might be the oldest comet-like object we've ever observed. Maybe even the oldest anything we've ever seen up close. You see, this object isn't just strange because of how it moves or how it looks. Its angle, its speed, and its direction match models of objects that were formed long ago and slowly drifted into interstellar space. This object might have formed before Earth existed, before the Sun, before the planets, before everything we think of as home. Let's break that down. First, we need to talk about something called the thick disk of the Milky Way. Our galaxy has several layers. These materials are more likely to be found in regions where stars have lived and died, where explosions called supernova have seeded space with rare ingredients. This region is believed to contain some of the earliest remnants of the Milky Way, dating back more than 7 billion years. It came from a place full of history, full of ancient stars, full of cosmic dust that's been recycled for billions of years. After all, we can't take a sample. We can't carbon date it. We can't even get close. It's most likely a piece of rock and ice, shaped by natural forces and flung into space by chance. These are the building blocks of planets, moons, and maybe even life. The thin disk is where we live. It's where you find the sun, the planets, and most of the stars you can see at night. A cosmic relic from a time when our galaxy was still forming. And it's a fitting name, because everything about it, its speed, its direction, its makeup, tells a story from long before we were here. It's relatively young, in galactic terms. That time in the universe is long and deep and mysterious, and that sometimes, even in the vastness of space, things find their way to us. And even if we never touch it, we've already learned something powerful. We are not the first. But every once in a while, a piece of that long story drifts close enough for us to glimpse, and we will not be the last. But there's another part. The thick disk. It's larger, older, and filled with ancient stars and materials. According to orbital simulations, 3I Atlas may have come from that thick disk. Think about that. And if we know how to read them, those objects can tell us things that words never could. Using telescopes like Gemini North and others, scientists have gathered light from 3I Atlas and broken it down into its basic parts. This process, called spectroscopy, reveals what the object is made of. That alone makes it priceless. It's like a message in a bottle from a time when the universe was still young, when the laws of physics were the same, but the conditions were wildly different. And now, after drifting through space for billions of years, that bottle just washed up on our shores. But how do we know it's that old? What we can do is study its orbit, its motion, and its chemical signature. And here's where it gets interesting. The data so far suggests that 3I Atlas contains heavy elements and complex molecules, the kind that don't form. In other words, 3I Atlas didn't come from a fresh, clean corner of the galaxy. Some even speculate the 3i Atlas could be made of pre-solar grains particles older than our solar system itself. If that's true, then this object isn't just old, it's ancient. Now, let's pause for a moment. This doesn't mean 3i Atlas is alive, or alien, or part of some grand plan. But that doesn't make it less amazing, because here's the truth. Space doesn't send us messages, it sends us objects. 3i Atlas might not look special, but it's teaching us something huge, that objects can survive for billions of years, traveling alone, untouched by light, heat, or gravity. Some scientists have even called 3i Atlas a cosmic time capsule. Imagine holding a stone in your hand that had existed before your own planet. That's what this is, a visitor from the beginning. And it makes you wonder how many more are out there. How many ancient messengers have passed us by, unnoticed? How many stories have we missed? For now, we're lucky. We saw this one. We caught it. The universe has been moving long before us. It will keep moving long after. 3-1A. TLAs is one of those pieces. And if we keep watching, keep asking, keep wondering, we might find even more. Chapter 4. Could 3i Atlas be artificial? Here's where things start to feel a bit like science fiction. When astronomers first noticed 3i Atlas, its unusual trajectory and speed raised eyebrows. That speed alone isn't proof of anything unusual. It could have been flung from its original system by a gravitational interaction, say, with a massive planet or a dying star. But then we look at the trajectory. It's not just flying through on a typical hyperbolic path. The angle and direction seem ... odd. Not impossible, just unexpected. That's what got scientists speculating. It's easy to get caught up in wild ideas, especially when dealing with things we don't fully understand. That's why the scientific method is so important here. We gather data, make predictions, test hypotheses, and remain open to being wrong. For now, the consensus is this: 3i Atlas is likely natural, but it's unusual enough that we should keep watching and keep wondering. Now, we know nature can produce all sorts of strange things. If interstellar visitors are more common than we thought, could we have missed hundreds, even thousands, of them in the past? And we're finally starting to listen. Space is vast, and the number of objects out there is beyond counting. Some may be rocks, some may be icy fragments, and maybe, just maybe, some are more than that. The technology and systems used to spot 3i Atlas, S like the ATL, S like the AT, and they're getting better. Every time we catch a glimpse of something from beyond our solar system, we get a little closer to answering one of the biggest questions in human history. Are we alone? As our sky surveys grow more powerful and more frequent, we may soon find that these visitors are more frequent than anyone imagined. But when something behaves in a way that doesn't quite match the patterns we've come to expect, especially from interstellar objects, it's natural to wonder. Could it be artificial? Could we have missed something? Could it have been something more? Or will the next visitor bring clearer answers? Honestly, not yet. The object is too faint and too distant for us to get a close look. We can't see its shape clearly. We can't scan it for signals. And we don't have a spaceship ready to chase it down. It would change everything. Religion, philosophy, geopolitics, how we see ourselves. That's the kind of potential 3i Atlas hints at, not because it's proven to be artificial, but because it represents a new frontier in our cosmic awareness. All we can do is observe it from afar and analyze its motion. So far, everything we've seen could still be explained by natural causes, but scientists are trained to look at outliers, things that don't fit the usual mold, and keep asking questions. Let's start with the speed. 3-1. Atlas is moving faster than most natural objects of its size typically do when entering the solar system. Perhaps it's debris from some ancient collision, or even a long-defunct spacecraft from another star system. That's a huge leap, of course, but it's a possibility that hasn't been completely ruled out. Space is old. If there were ever intelligent civilizations out there, it is not crazy to think some of their tech might have survived long enough to drift into our corner of the galaxy. This isn't the first time we've had this debate. Back in 2017, there was Oumuamua with the first known interstellar object to visit our solar system. It also had a strange shape, a tumbling motion, an acceleration that couldn't be fully explained by gravity alone. Some researchers like Harvard's Avi Loeb even suggested it could have been a form of alien technology, possibly a solar sail or a probe sent intentionally. That suggestion caused a stir. And now, with 3I Atlas, those same questions are coming back. But is there any real evidence that 3I Atlas could be artificial? One theory that's been quietly floated: 3I Atlas might be a fragment of a larger structure. Still, we have to be cautious. There's also the question of detection. Why are we only now spotting objects like this? This brings us to the bigger picture. The more we search, the more we realize how little we've seen. Even if 3I Atlas turns out to be nothing more than a strange, fast-moving rock, its presence alone reminds us of how much is still unknown. And here's the twist. Let's say we find something truly artificial someday, clearly designed, clearly not natural. That moment wouldn't just change science. So as it fades from view, heading back into the cold darkness of interstellar space, we're left with questions. One thing is certain: the sky is no longer quiet. Chapter 5. What 3I Atlas means for the future of space exploration. 3I Atlas might be out there drifting silently into the unknown, but its presence has already sparked something important here, on Earth. A shift in how we think about our place in the universe and how seriously we take the search beyond it. The arrival of a third known interstellar visitor isn't just a curiosity, it's a sign that the universe is more connected than we once imagined. Let's start with the obvious. We're detecting more of these objects now, not because they're suddenly appearing, but because our technology has finally caught up. Telescopes like Pan-STARRS and Atlas are scanning the skies more frequently, more precisely, and with wider fields of view than ever before. And AI-powered systems are learning to sift through all the noise, flagging the weird, the rare, and the unexpected. Just like 3I. Today, an object like 3I Atlas sparks curiosity. Tomorrow, it might spark contact or confirmation of life beyond Earth. That's not an exaggeration. Even if 3I Atlas is just a rock, just a fast, ancient travel, its story connects us to the rest of the cosmos in a very human way. It reminds us that we are observers, explorers, storytellers. Every time we point a telescope into the void, we're not just gathering data, we're reaching out, hoping for a reply. The tools we're building today, James Webb, the Vera C. Rubin Observatory, future deep space probes, are pushing the limits of what we can see and understand. A growing awareness that space isn't just cold and distant, it's alive with motion. It's filled with stories, not just with rockets and cameras, but with the humility to understand that every question we answer out there leads to 10 more waiting in the dark, and some of them are finally starting to arrive at our doorstep. That sky you see, it's not empty. We'll be here, watching the sky, one mystery at a time. It's a highway of ancient travelers, some just passing by, some with stories we've yet to read. And interstellar visitors like 3I Atlas push us emotionally and intellectually to keep asking, what's out there? When it is, the probe would launch, chase it down, and study it up close. It might come in faster, it might swing closer, it might be something far more revealing, because one of these objects, someday, may not fit any known model. It's a reminder that we're not alone in the cosmos, not because of aliens, necessarily, but because the cosmos is active, dynamic, and very much in motion. Every visitor like this is a thread connecting us to something beyond. It may defy expectations in ways that demand new physics or new assumptions about our uniqueness in the universe. Second, it means serious investment in response systems, spacecraft that can intercept, analyze, even rendezvous with interstellar visitors, not decades after they pass, but in real time. We're talking high-speed flybys, chemical sampling, high-res imaging, maybe even returning material back to Earth someday. It sounds futuristic, but it's already in early-stage planning at NASA and other space agencies. This isn't just about rocks flying through space. Each object like this is a messenger from a place we may never visit. It carries the story of a distant star system, of gravitational forces, time, and chaos. It might even carry material that formed before our own sun. Imagine what we could learn if we could catch one of these objects early enough to intercept it. Our solar system is open, things come in, things go out, and we need to be ready, both scientifically and philosophically, to meet them. And that's exactly what some scientists are proposing. There are real, serious plans being discussed about launching an interstellar a spacecraft designed to sit in standby mode until the next object like 3I Atlas is spotted. 3I Atlas is a kind of wake-up call. It reminds us that we're not isolated. Then there's the broader question. How do we prepare the next generation to deal with discoveries we can't even imagine yet? But here's something deeper. And perhaps that's the most profound part of this whole phenomenon. Not the rock itself, but what it represents. So where does this all go? Well, first, it means doubling down on sky, surveys covering more of the sky, more often. We can't afford to miss the next 3I. And third, perhaps most important, it means preparing our minds. Until then, 3I Télés will continue its silent journey, fading from our instruments, but not from our imagination. And maybe, just maybe, the next time one shows up we'll be ready. If you're still with us, drifting through this story like 3I Télés itself, take a moment to look up tonight. And if you're ready for more journeys like this, subscribe.